Good evening. Surendra.
Yes, Srinivas. Hi.
Hmm.
2 minutes. One more guy is about to join.
Okay.
Hey guys. Hey Surendra.
Hi, Srini.
Hey Sri.
And Varun. Okay. So,
Yeah, I think another guy is going to join. Okay, so let's see.
oh, okay.
So I'll just introduce and I'll drop off. Okay.
No problem.
Hi Sri.
Hey, Srini.
Hey. So see, you're giving time, right?
I'm the trainer.
Today.
Correct. I'm the trainer.
So what is your name? Full name?
My name is also same your name, Srinivas.
Srinivas. Okay. Just is three, right? Like Srikant. Okay. So see, like Varun is here. Okay. Varun is one of the trainee going to be,
Mm-hmm.
and Sudarshan is going to join in a couple of minutes. He is trying to
Who is
join.
that? Who is that? Other guy? Oh,
Sudarshan. Sudarshan.
Okay.
So those two. Varun, Sudarshan is also here. Okay. So Varun,
Yeah, hi.
Varun,
He's talking, Varun.
Hello?
yeah, Varun. Jairaj is also joining.
No, he's still sleeping. I mean, he slept last night very late, so that's why he didn't
He
woke up.
says, okay, that's okay, that's okay.
I
So
tried to wake him up, but he's
yeah. So Sri, like certain rules are there. Okay. So I don't know what process you're going to follow, but as a employer, what we do, what we recommend, always ask a candidate to log in from the laptop, no mobile allowed,
Okay,
and
okay,
also video has to be turned on.
okay.
Okay, then only like they are going to be serious about the training. What you are telling, they're going to catch up.
That's fine, that's fine.
Yeah. So Sudarshan and Varun, can you please turn on your camera?
yeah.
Okay. Take a notebook. Okay. Take a notebook
One
and
second.
write down.
Just give me a second.
Okay, Srini. Yeah, you can go ahead. Okay. So floor is yours.
Okay, thank you so much.
Thank you very much, Srikant.
Yeah, it's
Srini.
okay.
Yeah, I'll drop
So
off.
I think Sudarshan and okay, it's okay, Siri. Sudarshan and Varun. So just to understand your background, right, at high level, very high level. So tell me about yourself, Sudarshan, very high level.
Uh, Hi, this is Sudarshan. Have a five years experience as a data engineer.
Huh?
Uh, Hello.
Okay, please go ahead. I can hear you.
Yeah, working on designing, developing, and maintaining data pipelines and data platforms using AWS and Azure and GCP technologies, and also working on a um, ETL ETL processing and data warehouses and cloud-based analytic solutions.
Uh-huh.
Yeah, currently I'm working with Cigna Healthcare.
Okay.
Um,
Okay, that's fine. Thank you so much. At high level, that's fine. How about you, Varun?
Yeah, one second.
Hmm.
Okay, sorry. I just heard him. What's the question?
No, you are about. Tell me about yourself at high level.
Okay. So basically, I don't have much experience in the IT working. I don't have any working experience, but right now, I'm learning. I'm by using the upgrade. I'm learning SQL, Python, and AW Glue, and couple more courses.
Okay.
So right now, yeah, that's what I'm doing currently.
Okay, I got it. Okay, got it.
Yeah.
So, okay, let me give you a very high level about myself. So, I am Srinivas, and so I work as a data engineer in a multinational company, and
Mm-hmm.
I have nearly 20 plus years of experience. And I majorly work on building the data pipelines using AWS, Snowflake, and a bit on like Python and PySpark and big data. And I also work on data science projects also parallelly. And coming to this training, which you already might have come across about the content and all, which you have already seen. This course is basically designed for people who are willing to build data pipelines using AWS data stack, plus along with Python and Python with AWS and a bit on PySpark. And majorly, we use AWS data stack, but the foundation for this particularly is AWS data stack is SQL and Python. If you're already aware of SQL and Python, that will give you more like clarity, and you can speed up learning also. If you are not familiar with either Python or SQL, I advise you to learn a bit quicker And I'm going to cover a bit on SQL and Python fundamentally. And then I go to AWS Data Services. If you're already aware of, please try to refresh yourself. Clear?
Yes.
Okay. So coming to for today's discussion, right? Let me try to give you a high-level overview on the AWS data engineering and why data engineering important and why AWS for data engineering and what are the different data engineering services available and what is the importance of these services, and let us discuss about it, okay, at very high level.
Okay.
I'm sharing my screen. Let me know you are able to see my screen. So let me just a minute. Hope you're able to see my screen.
Yeah.
Okay. So I understood that you are already, Sudarshan, you mentioned you are working on this particular AWS data stack. So just to give a high level overview on data engineering. So data engineering not a new term, right? So data engineering is already available for a while. The initial like days of the software development, if you see in 1980s and then 1990s, majorly the data engineering people were doing through files and databases. If you see in 1980s, right, the databases were not even present. People used it to manage the data using electronic files only. And people, the whoever wants to work on this data engineering, they used to manage through the files. And as soon as companies started thinking like, okay, we are able to store the data, but when you are managing with some kind of relations, the normal files are not helping. So we got databases into the market. So the databases, which are basically the fundamental databases which were very popular in 80s and 90s before Oracle was there. There was a database called DBase and then FoxPro. These databases very popular in banking sector. And every company started using these particular databases for some time till Oracle came into the market. As soon as Oracle came into the market in 90s, 90, 91, 92, this particular years, slowly with security and extra features, Oracle captured the entire database market and the old databases became vanished. And since Oracle got success, we got other databases also into the market like SQL Server and then MySQL, Sybase, PostgreSQL. So many databases which are part of RDBMS came to the market. So most of the database management or data engineering was happening through databases. So database programming like PLSQL programming or TSQL programming. So every project people were managing through databases in the backend, but the data engineering was happening through SQL coding only. And this was helping for some time. But whenever the industry moved to the 2000 decade, there was a little bit importance came to analytics, the reporting and then dashboards. When people started analyzing the data, the real-time data was not helping. The traditional databases, which are real-time data, which was keep on changing, that was not helping to the companies to build dashboards with the right analysis. So then people started thinking, how can we go and resolve this issue? So that is where the data warehouses came to the market. The data warehouses, the birth of data warehouse started in 2000, where Informatica, data stage and other ETL tools slowly captured the market in the data engineering and ETL space. I hope you heard about Informatica, right? The ETL tool, which is very popular in the market, which basically this Informatica was generally was helping to build ETL pipelines, data pipelines only, but in ETL jobs. And when you are building these ETL pipelines also, you are extracting the data from multiple sources, multiple databases and file sources only, not any type of semi-structured unstructured data was present, only structured data. Even Informatica was only able to manage structured data like database tables and some part of plot files like Excel and CSV files. And every database project converted to data warehouse project with the help of this ETL tools. And this ETL data warehouse became one of the fundamental data hub for building the dashboards and reports. And with the success of data warehouse, enterprise level data warehouses got improved, and every company started building their own enterprise level data warehouses. So from 2000 to 2010, the entire industry was very busy in building ETL like pipelines and data warehouses, and slowly the data warehouses captured the market with analytics also. But as soon as we moved to 2010 decade, there was a big revolution in the data. Suddenly the data got increased. The data engineering, which was happening very easily with these ETL tools, suddenly got disturbed because of the huge amount of data has been generated after 2010 onwards. Do you know what is the reason for that? Why suddenly data got increased in 2010, 11, 12, this time period? By any chance? Sudarshan and Varun, any guess why the data suddenly got increased after 2010? You can guess and tell me. It should not be.
I mean, most probably due to the smartphone revolution,
Very good. Agree.
widespread of internet, high speed internet.
Because you are 100% correct. That is true. The
And
revolution.
also that's the time where social media is evolved so
That is
much,
what
like Facebook.
Very good. I was expecting the same answer.
Yeah.
Social media. The social media, as soon as it started in 2011-12, majorly the Facebook, Twitter, Instagram, WhatsApp, YouTube, every social media slowly started generating unstructured data more, correct, right? Like videos, images, documents, and all these voice. Most of this data is not structured. We call them as unstructured data. We can't store this data even in databases also, because databases were designed for structured data. So the normal databases, traditional databases were not supporting for storing this data. That is where big data tools came into the market, like Hadoop came into the market after that. I hope you heard about Hadoop. A Hadoop is a combination of HDFS and MapReduce, big data framework. So companies started using these big data tools or services to maintain their big data environments, because data volume increased, varieties increased. Before 2010, everybody was focusing only on structured data, but as soon as this big data came into the market, we also got semi-structured, quasi-structured, and unstructured also. Semi-structured means JSON files, Parquet files, Avro, ORC, XML. All these file formats came to the market, and these file formats we cannot store in the normal databases. So we got a separate kind of databases like HBase, MongoDB, which are called as NoSQL databases. These databases came to the market to store a large amount of data faster and extract them faster. That is the main reason. And slowly big data, the conventional data warehouse started, slowly converted to big data warehouses, and then big data lakes. And when the big data lake has been built, every company was able to hire big data engineers also. And even big data engineering was not easy. You need to learn many tools. Hundreds of frameworks came after that. To maintain one big data environment, you need to know minimum 10 to 15 tools, services, or frameworks. For the developers, it is not easy. So the developers also facing some challenges to learn these many frameworks. At the same time, companies also started facing challenges to maintain this environment because of the cost, and the people are not available who knows this many frameworks. So this particular big data services changed the world. At the same time, they also had put some burden on the developers and the companies. And every company started building this big data environment because there is no choice. Even I was working with MasterCard on data warehouse project. I also moved to big data because of this big data revolution. I started converting my traditional data warehouse to big data warehouse. So MasterCard consolidated data warehouse has been changed to big data warehouse and then big data lake. And slowly the industry moved to big data era. So big data frameworks came into the market like Talend, big data integration tool, Pentaho. So mainly the companies were focusing on the big data management, how to store. The ETL has been changed to ELT. Extract, transform, load has been changed to extract, load, and transform. And slowly MapReduce has been vanished and it replaced by Spark. Spark also came after 2014 because of MapReduce limitations. A MapReduce is a framework to process huge amount of data. And to store that, people started using HDFS, Hadoop Distributed File System. HDFS and MapReduce, they both ruled the entire big data industry for some time. Whenever people started experiencing challenges with MapReduce, because MapReduce was running hours and hours to process the data, because it will store and process the data in the disk. So that is taking so much amount of time. Then Spark came into the market and slowly it replaced MapReduce. So MapReduce plus HDFS has been changed to Spark and HDFS. So majority companies started using these particular tools and frameworks, but they were facing challenges to maintain this environment because every month new framework will come and we need to change it. We need to upgrade it. We need to every month new release. We don't know what issues will arise after integration. So because of these challenges, where AWS first started addressing these issues, they started some services, infrastructure services in 2006 itself. But they were not focusing main on this data infrastructure management only. They were focusing. They also started providing big data as a service, databases as a service, infrastructure as a service. They started everything as a service with a cloud option. Slowly AWS started capturing the market until Azure came to the market. Until Azure was into the market, AWS was the leader. We got GCP also. We got Alibaba, IBM Cloud, Oracle Cloud. There are so many clouds came, but only AWS, Azure, and GCP, only these three were able to stand in the market. Other clouds are there, but not that much popular. But slowly AWS captured so much of market, and they started different services. Data side, there are services, machine learning services, infrastructure services, DevOps services. Everything is a service. So when they started data services, the data engineering became very easy because creating a database server is not easy, or creating a big data cluster is not easy. Creating a serverless feature is not easy. So they started services like S3 to store any amount of data anytime from any location and accessing using any device. Serverless storage. They started serverless query engine, Athena, serverless big data environment, EMR, serverless ETL, Glue, serverless database, Redshift, and serverless BI, like Power BI, like QuickSight. They also started serverless feature like real-time processing engine like Kinsys. All these slowly capture the market in big data space and data engineering space. So this AWS data engineering will help you to build these data pipelines where you can easily collect or ingest the data from multiple different sources which are not structured only. It can be structured, semi-structured, and unstructured as a combination, and then try to extract, load, and we can even transform, or I can extract, transform, and load also. I can do both ETL or ELT. So we have multiple different services to manage the ETL data pipelines. Instead of building the environment, we'll focus mainly on building the data pipelines and data lakes and the data warehouses, plus along with streaming features also, real-time streaming features, where these data warehouses or data lakes will help the data scientists and data analysts to directly extract the actionable insights from this cloud data warehouses or cloud data lakes. So the data lake which was in on-premise slowly became a big data lake, and then cloud data lakes now. Everything is in the cloud. What is the benefit of the cloud or cloud computing? I can access my device, my services or my software, whatever it is, my applications, my infrastructure, my servers, my database servers, my ML models, everything from anywhere by using any device, anytime. So we need to know how to use the services, what is the importance of each service, how each service will be charged. You should have that clarity. Just knowing what is the service is not going to help us. We also need to understand what cost involved in using that service, how to manage the cost, how to reduce the cost, how to control the billing, when to use this service. We should have that particular clarity also. So that core data pillars for any kind of data engineering is data lake and data warehouse. So data lake can be maintained using Amazon S3 service in AWS environment. Amazon S3 is one of the service to store any amount of data. Amazon Redshift is a fully managed petabyte scale data warehouse service. It can allow you to store structured and as well as semi-structured data also. Both I can store. Structured means rows and columns. Semi-structured means JSON, Parquet kind of data also I can store. And I can easily connect Redshift with any kind of tool. I can connect with Athena, I can connect with QuickSight, I can connect with Power BI or Tableau or any kind of service. I can even connect Redshift and build an ML model also. Machine learning model, data science I can implement. So this particular two services became one of the fundamental services. Along with this, we can manage not petabytes, we can even manage exabytes of data also. So exabytes means not a small amount, very huge. Redshift can manage not only petabytes. If you have a Redshift spectrum, I can even manage exabytes of data also. Millions of transactions daily will happen in banking sector. To manage that, I need a decent amount of storage. So I can store any amount of data in either S3 or Redshift without any limitation. So every data pipeline will have a life cycle. What is the life cycle? Data ingestion need to be done first. So to ingest the data, we have multiple sources, IoT devices from manufacturing side, which will have sometimes the data will come as a time series data, time oriented data. Every millisecond we need to capture. The IoT device will keep on checking the mission status, when the mission will go down, how much time it was down, and what is the impact on the business because of the downtime. And we also sometimes use third-party APIs to load the data into tools like Kinesis. Kinesis is a real-time streaming engine. So to store any real-time data continuously, I want to monitor the real-time status of the machines. So I can use Kinesis for that. And the data migration service, I want to migrate data directly from Oracle to like some other database. I can use the data migration service. So we have different services for data ingestion and the data storage. S3 is one of the fundamental service to store any amount of data, raw data. When you extract your data, it will be a raw data only. Once you transform it and then extract, transform, to transform it, we need another service. But to store, I need some location. That is where S3 will come into picture. The raw layer, we call it as bronze layer also. And then we'll convert or transform it by using the silver layer where you process your data or transform your data. For that, we can use Amazon Glue for transformations, the ETL, serverless ETL service, or EMR also. In any big data is involved, I go with EMR service. So I need to know which service to use for what kind of data also. Once after you process the data, I need to perform analytics. To perform analytics, I can use like tools like Redshift or Athena to run SQL queries on top of the data which I processed. Or I can build visualizations using tools like Amazon QuickSight, where we build dashboards. Serverless BI, serverless business intelligence, where Power BI will be used. In that place, I can use Amazon QuickSight also, which can help us to build dashboards and I can access from any device, anytime, from any location. So we will go and learn about Amazon S3, Amazon Redshift, Amazon Athena, Glue, EMR. We'll also learn about Amazon Lambda, AWS Lambda, DynamoDB, which is a NoSQL database, and Kinesis for real-time data processing. And we also will learn about QuickSight to build some basic dashboards also. How to consume the data, consumption. After my data is centralized in the data lake, how can I build a meaningful dashboard out of that? For that, we will learn about QuickSight and Abiton Power BI also possible. So all these services we need to learn, but the fundamental foundation for all these services is SQL and Python. So compute side, what services are there? We have like EC2, EMR, Lambda. These three will fall under compute side. Compute means we need to process the data. We need some kind of service to process the data. So this EC2, EMR, Lambda can help me. Storage side, we have S3, EBS, and EFS, which will store the data with some durability and high availability. And databases, we have RDS, Relational Data Service, DynamoDB, Redshift. These are all will offer, RDS will offer Relational Database Service, all the RDBMS data. DynamoDB will help me to store NoSQL data. Redshift will help me to build a data warehouse service. So we will try to learn all these one by one. And why Amazon is very popular in the data engineering side? Because it can maintain the data lake and it can provide the high availability and durability also. 11 nines durability and high availability. And it also supports different file formats, Parquet, ORC, JSON, XML, Avro. Every file format it will allow you. CSV. All are open data formats. Plus, I can directly use the ML services like SageMaker, directly connect to this particular data, and I can build my ML models and AI models, and I can perform some analytics also. So S3 side, we have different features. I will discuss about them once you go to S3 class. And the storage class is one important feature to understand how to maintain your data, when to use what kind of storage class. That is what you have to understand. Use case file you have to understand. So why we need that service is important. At the same time, when to use the service also important, and what is the purpose, what is the use case we have to understand. When to use S3 standard, when to use S3 intelligent tiering. So we should know all this as a data engineer. And AWS Lake, data lake formation, this is going to help you to build and perform governance on your data. When I say data governance, how you are going to control your data access, how to build some policies to control the data, how to create some roles and policies, how to mask your data, data masking, how you are going to secure your customer sensitive data. And we have some templates here. We have ML machine learning templates also, where I do not need to build any code. Use the template and it will automatically generate the code also to build your ML model. And governance side, we also need to see how can we encrypt the data, secure our data, how to control and create some data access policies, how to create some data versioning, how can we go and have the different versions of your data, how to perform auditing, because most of the data which you are going to change need to be tracked. So the audit teams in banks will come and see this. So we need to have the protection, data protection policies and PII protection policies, we call it as sensitive data protection. We need to implement all these at the data level. And this is basically will happen in every data project. And the ingestion layer, where you are going to do batch processing or streaming data processing, both are important. So data migration service can help me to do the change data capture like ETL and incremental data loading. We have Amazon MSK and Amazon Kinesis, both will help me to process streaming data, continuous streaming data. Example, I want to build a credit card fraud detection. If I go and tell to the customer after 1 week there is a fraud transaction, will the customer accept it? Will you accept? If I go and tell you after 1 week there is a fraud transaction on credit card?
No.
No, because credit card fraud is very dangerous, risky. I need to immediately block if it is a fraud. Money laundering also. If I want to build a money laundering detection, credit card fraud detection, I need to capture live data. When the card is swiped, it immediately has to verify. With a valid transaction, approve it. Invalid, reject it, block it. That is what going to happen with respect to international transactions generally. So Kinesis and managers like SK, all these will provide you, Kafka, all these provide you the streaming data processing. So Apache Kafka is a real-time streaming engine in on-premise. The same service is available in AWS also as MSK. Kinesis is another service where it will help you to capture clickstream data, IoT telemetry data, application logs, all I can manage. Video analytics also. If you go and see most of the countries like US and other Western countries, we have some advanced tools to capture your speed limit, right? Speed cameras. Will they do that?
Yes.
So how they will capture? How they will identify your vehicle? Because they will have tools to manage and monitor the videos and capture images or tag images also. In a speed limit, in what they do, the speed camera will capture the video, and if it crosses the speed limit, it will capture the number plate of the vehicle in the video. And according to number plate registration, they will identify the who is going to ride that, who is going to drive that, and they will try to send the like notification, right? Yes or no? It is very quite common in US, right?
Yes, yes, exactly.
How do they know? This is the way they do.
Uh,
We have tools available for that. Even Amazon also have tools. Kinesis video analytics is there to capture that. Continuously it will monitor, and I can apply some data analysis on top of that also. For example, I want to tag suspicious people in a video, I can do that. So most of the applications nowadays are very advanced applications, right? Which are people are building mainly AI videos. You can see how many AI videos are generating daily in YouTube also. Content generation, video generation, generative AI. So these kind of applications require some advanced tools also. So database migration service is one of the service. DMS is one service which you need to understand. Kinesis is one service, and on the processing side, we are going to learn about Amazon AWS Glue as a serverless ETL, like extract, transform, load, and after that we also will try to learn about EMR big data service. We will go and build a EMR cluster and process huge amount of data. And then we also will go and learn about analytics side. We'll learn about Redshift, Athena. Both are going to be important. How can we manage the Redshift cluster, and how to create it, and how to manage, and how to create a database and manage it? Petabytes of data. And what is Redshift and what is Redshift spectrum? We'll try to learn. And also Athena, a serverless query engine. How to query the data in files in S3 bucket directly using SQL. No infrastructure required for this, but we can run and pay for only how much amount of data per terabyte you scanned. So Athena is also important service, and both Amazon Athena and Amazon Redshift are very popular and very important services for AWS data engineers. We are going to learn about them, when to use which service. And streaming side, as I mentioned, the streaming data, clickstream data, we will try to see how Kinesis is going to help us, and what is the importance of Kinesis data streams and Lambda together. How can we convert the Kinesis data streams into structured data and store in S3, and from there how to convert into a group of rows and columns into tables, and how to extract data using Athena. And once my data is we are able to extract, how can I convert into a dashboard using QuickSight? These are all we need to learn and integrate them together. And that's about majorly the real-time data processing, batch processing, how to go and build a batch process, how to extract the data, how to process it, how can I go and load it into a data warehouse like Redshift, and once my data is loaded, how can I go and analyze it? These are all we need to understand. And what is the importance of each service also we should know. What is the importance of like command like copy command in Redshift, how to load the data into a Redshift table which from the S3 bucket, how to secure your data with data sharing, and also like data masking. We need to understand about the scaling policies and also like the security, all this. When you are building data engineering, we also need to worry about the best practices also. How to optimize the pipeline with the highly secured pipeline, and how to implement the data engineering operations using CI/CD. How to convert a data pipelines into a data ops pipeline by integrating with DevOps. So plus cost optimization, storage side, how to optimize, how to reduce the storage cost, and how to reduce the compute cost by using partitioning, bucketing these features in S3. So this will optimize your SQL queries when you are running. And security side, what is the importance of IAM, and what is virtual private cloud, and how we can perform cross-region replication and cross-account access. We need to learn. On infrastructure side, infrastructure as a code. How can I go and use the tools like Terraform? How can we go and use CloudFormation in the place of Terraform? How to automate your data pipeline deployments? We need to know all this. And what is the importance of CloudWatch? How to monitor your services and the data pipelines? How to maintain the data quality? We need to know even this also. So the important services S3 for storing the data, extracting the data ingestion, and then loading into S3, and from there how to perform the data processing using compute services like EMR and then Kinesis, and how can we go and try to analyze the data using Redshift and Athena, and then finally connect to a dashboard. That is what we have to learn, and we are going to learn. And some of the projects also involve how to integrate these data pipelines with advanced analytics like generative AI also. So Amazon Q is one service, just like a agentic AI assistant, where I can go and integrate into a Redshift or Glue, so that the engineers can generate the complex SQL queries with single plain English, natural language English. I can go and ask a plain English sentence and it will generate a SQL query out of that. So Amazon Q is one of the service for that. We need to integrate all this to build a end-to-end data engineering pipeline that can help the data science engineers or ML engineers or Power BI developers or dashboard developers, and how they can get benefit of your qualified data. And you also should know what are the best data quality checks and data validation best practices also. Clear? Any questions?
I'm good.
Varun?
Yeah, I'm also good.
Yeah, I'm good. I'm good.
Are you able to understand what we discussed?
Yeah. I mean, I have a familiar idea regarding this one. Yeah.
Okay, cool. But what you are going to learn, that you have some clarity now, correct, right?
Yeah, I took a notes which I don't understand. Yeah.
Okay.
I'll
If you have
take care of it.
any questions, you can ask in the next class also. But for now, I hope you got some idea, right?
Hmm. Yeah, and are you able to share the PPT with us, or you have to keep it by yourself?
No, no, no. I'll share. I'll share. I'll share.
Okay.
We'll have a Google Drive, and I usually follow a Google Drive, and I'll upload into that, and I'll give the access.
Yeah, sure.
But that is not usually I follow. But let us decide with once after I discuss with Surendra.
Yeah,
Okay.
yeah, that's fine. That's fine. Yeah.
And Varun and Srini are else Sudarshan, are you guys okay with this timing for the regular sessions?
Yeah, I'm comfortable.
Yes, I am
I'm
also
ready
comfortable.
to.
Just half an hour, like 10 p.m. Okay, okay. I'll wait for 10 p.m. Or is it late?
So Varun, for 10 p.m. IST for you, it would be 11:30 a.m. CST.
Is it
Yeah,
okay?
yeah, that works for me.
And Sudarshan, for you?
Yeah, 10:30 a.m. right? Here.
No.
No,
11:30
rest
a.m.
it's 11:30.
11. Yeah, I have fine that. No, I have no problem with that.
Okay, sure. I think they are comfortable with the 10 p.m. IST as well.
Okay. Okay then. Then we are good.
Okay, cool. Then I will just talk with them and get back to you with the update.
Okay.
And maybe ready to start from tomorrow. We can start it.
Okay, Surender. That's fine. Thank you so much, guys.
Okay.
Yeah.
So all good for today, right?
From my side, I'm done. So if you have anything, you can ask.
Yeah, Varun. And do you have any questions or doubts related to subject or course side?
Yeah, I'm okay right now, but the only thing is it for only 30 minutes or 45 or 1 hour class?
1 hour class. 1 hour class.
Okay, that's cool.
Yeah,
Okay.
it would be 1 hour daily, and
I
you
just
guys can get recordings as well after completion of the session.
Everything will be in Google Drive.
Recording?
Recording, video recording.
Okay.
Yeah,
whatever,
session recording.
the session recording, materials, assignments, you will get everything. Okay.
Okay. Cool. Yeah.
Okay then, Surender.
Okay. And Srinivas, one more thing, what is the of this course? Like, is it 40 hours or 45 hours?
45 hours you can consider, not 40.
Okay, sure.
Yeah.
Yeah, that's it from my end as well.
So
Yeah, thank you.
Monday to Friday, right? Not
Only
on
Monday
Saturday,
to Friday.
Sunday, right?
Monday to Friday only.
Okay. Cool.
Okay, Varun. Yeah.
Cool.
So every day 1 hour, right?
Every day 1 hour. Correct.
So 9 weeks. Okay, cool. Yeah, thank you.
Thank you.
Thank you, Sri.
Yeah.
Thank you guys. Thanks for that. And thanks for the presentation, Srinivas.